right, good morning guys. Today we're going to be doing a couple of things. We're going to do a diagram of a watershed, and then we are also going to do a little demonstration of how water flows over a watershed. So we're going to need several colors today. I think you're going to need yellow, red, orange, brown, black, blue, purple, and green. So we're going to kind of use all the colors of the rainbow in our diagram. So let's start with something that's familiar, and we're going to start with our blue. We're going to kind of show water movement with all of our arrows. So let's look first here at these arrows that are causing water to travel from our little water body right here. Right, this is our water body. You can kind of color it in blue. Water on the surface, we call this surface water, right? And so when water is pulled up from our surface water, we call that evaporation. And what is the power source of evaporation? The power source of evaporation is going to be sunlight. So we're going to, over here on this side, we're going to draw our big sunlight. This is our power source for the water cycle. And I did that in yellow. Okay. All right, so we've got evaporation here. What about evaporation here? Is this also showing evaporation? Maybe of dew or small amounts of surface water, or even water that is underground, because as you guys know, in San Antonio it gets hot, right? And that heat can pull water and evaporate it. So that is also evaporation. Over here we've got our little ocean, maybe down in Corpus Christi, right? We've got our ocean water here, and water can also be evaporated from our oceans, right? That's how a lot of water vapor gets into our atmosphere, through evaporation of our ocean water. And you can shade that blue too if you want to. I'm going to leave it around ocean so that we can still see it. Okay. We've also got evaporation from our rivers and streams. We're going to shade in those arrows, blue, to show our evaporation there as well. Let's slide this over a little. Sorry about that. Okay. So that kind of deals with all of our evaporation, but we've still got some arrows going up. Now if you look at your vocabulary from yesterday, you should find a word that discusses how water gets pulled from plants like grass and corn stalks. I'm going to color that in green, and trees. What do we call that water movement through plants into the atmosphere? We call that transpiration. Okay, and that is just talking about that water movement from plants into the atmosphere. So we're going to shade those arrows green, so we remember that transpiration has to do with our plants. Okay. All right, so now we're going to kind of start, after it evaporates, we're going to switch back to our blue. What do we call it when we have cloud formation? Cloud formation is our condensation, right? When water vapor changes from a gas to a liquid in clouds. Well, clouds can only hold so much, right? And so then that water falls down in the form of precipitation. And precipitation can be rain, snow, sleet, hail, any form of water that falls from the sky. So I'm going to take actually a blue highlighter, and I'm going to kind of shade in my precipitation area. Now once there's precipitation, what happens as that water hits the ground? Well, it's going to cause the water to flow down slopes and hills into the lower lying areas. And we call this runoff. And what is the energy source that's pulling that runoff? It's pulled by gravity. Okay? And that runoff is eventually going to start to go into the ground. It's going to seep through the ground. It's going to percolate. That was one of our vocabulary words. And we call this process of percolation infiltration. It's infiltrating the ground, right? It's flowing into the ground surface. It's going to flow through those permeable layers, and we're going to talk more about those in a minute. And it's going to refill our groundwater supply. And what do we call it? We don't say refill, we call it recharge. This is called a recharge zone. This is how that water is going to refill our aquifer. Okay, and our aquifer, this line right here, this dotted line, is our water table. And so if we shade all of our area, and I'm shading it with my little highlighter so we can still see everything really well. This water table is all the top of this filled zone, all the way to the ocean where the water table meets the surface water, right? So groundwater meets surface water there. Right? We're going to switch to purple really quick, because these layers from the top of the surface to the bedrock, and same from here, from this surface all the way through to the soil surface, these are our permeable layers. These layers allow water to flow through, and we're going to kind of zoom in on those over here. Okay, so we're going to write permeable right here as well. Permeable layers. And these are layers that allow water to flow through them. They have a higher porosity. They are more permeable. Now, if we look here, we've got kind of two different zones. We've got this area here that doesn't have any water in it, and then we've got this area here that is saturated. So we're going to switch back to our blue for just a second. And this top area, this top layer, is our unsaturated zone, which means that this bottom, this blue part that's filled with water, is our saturated zone. Remember, the unsaturated zone is permeable, but it is not filled with water. The saturated zone is permeable, and it is filled with water. This is where we find our aquifers, right? And remember, this little dotted line is our water table, so that's the height of that water level, okay? So let's go back and look at our permeable layers, and we're going to kind of color code these from lightest to darkest. So the first layer we're going to talk about is really just our topsoil layer. Okay, and the topsoil layer is kind of all of these really small particles. So I'm going to use just little dots of my pen to represent those little tiny pieces, tiny spaces between each of the particles of soil. And you know this because sometimes the water doesn't even soak into the soil for a little while. It kind of runs off the surface, right? So these are kind of small particles of soil. And you can shade this in and use your pencil to make the dots if you can't see your dots with your whatever you're using to write. Okay, so this is that very top layer, our topsoil layer, right? Now below there, we've got a sandy layer, and we're going to use orange to represent that layer. And so this is going to be sand, and sand is a larger particle than soil. So we're going to use kind of little circles to show those sand particles. Now we know that sand is not actually circular, but we're going to kind of leave some space so that it shows us how much space is between them, right? So not a lot of space between the particles here, bigger spaces here, right? Because sand has larger spaces between us. And so this can be this area here, right? We could have a sandy layer. Well, below that is, we're going to use red to represent our gravel layer. And gravel are small pieces of rock, and they get larger the farther down you go. But the larger pieces you have, the larger spaces are left between those pieces. And so this area is representing all of this space here that is gravel, right? This gravelly layer that can hold lots of water. So as you go farther down, it can hold more and more water because the spaces are larger because it's larger particles. Now we do have a limit, right? We do have a limit as to how much water this area can hold. For my brown. There we go. And so this area here that's below there is our impermeable zone, right? So we've got our permeable layers, and then we have our impermeable layers, and bedrock is part of that. So we're going to color that area brown. Okay. Looking for a sharper pencil. Guess I don't have it in there. Okay. So we're going to shade this area brown, and then we're going to come down here, and I'm going to use my brown pen to show these impermeable layers. These impermeable layers do not allow water to infiltrate, right? They don't have pores large enough to hold water. The first layer that is impermeable is a hard clay layer, and we're going to shade that with our brown. To show that it's full, we want to make sure we fill it all the way in so that we show in our diagram here that there's no spaces between those layers. And then that bottom layer, the space layer, is that bedrock, that impermeable layer of bedrock, and we're going to shade it with our black. And again, we don't want to leave spaces so that we can remember there's no space here for water to be absorbed. The particles are so fine and tightly packed in the clay layer, and the rock is so hard and dense that it does not allow space for water to be stored. So here is your watershed diagram. You're going to put this in your journals and let that be part of your notes. So that you can use this to help you remember how the watershed works. Now you guys are going to watch video 2 for today and answer the question about your watershed lab. All right, hope you guys have a fantastic day, and I'll see you again soon.